We'll make a start. So, welcome to last session, day 2 of Comsverse. We've got Eric remotely presenting from his lab, basement, I'm not sure. So Eric's going to cover deploying Microsoft Teams direct routing in a highly available and geographical dispersed environment. That's the title. So I'll hand you over to Eric. He can introduce himself in the session. If you want any questions, Eric says, just shout them out through. We'll pass you or throw you the microphone. But I'll hand over to you, Eric. Take it away.
Awesome, guys. Well, good afternoon to you guys. And if anybody's joining remote, good morning, good evening, good afternoon, whatever works for you guys. As Martin mentioned, we are going to be talking about Teams direct routing and how it can span across your entire organization, regardless if you're a single site or multi-site environment. Although we are going to start off with kind of how this presentation went. This was this past Sunday, realizing that this presentation wasn't created and that I was presenting Thursday. Last night, going through everything, as a final touch-up, then realized that my SBA lab is not working. So we're going to work around that, but TLDR, heads up, part of it doesn't work, but we're going from there. So today we're going to go ahead and start off with a little bit about me. We're going to dive into SBC high availability, Geo-Redundant Routing, Survivable Branch Appliances, and then we're going to break my lab environment right in front of you guys. And we're going to see how Teams reacts to a simulated outage. So my name is Eric Marsi. I am from Barberton, Ohio. If anybody's familiar with Akron or Cleveland, such as LeBron James, that's kind of the area that I am from. On June 1st, I was awarded the Microsoft MVP Award in Office Apps and Services, and I'm very honored and thankful to have received that. I am a UC engineer at T2M Works, and I'm also a graduate of the University of Akron. I am a Teams Administrator Associate, Audio Codes Certified Associate, and a few other certs. And you can find out anything that I'm up to, whether it be via my Twitter, my LinkedIn, or via my personal blog at ucit.blog. I post scripts, guides, fun things like that will help you across your Microsoft Teams and or Skype for Business journey, whether you're in a hybrid environment or not. So why do I have the name Eric the Lab Marsi? Simply put, I probably have a lab environment for that. Back at ComsVNext 2019, where kind of my first public appearance and first public start of my UC journey began, I'm making fun of Mark Vail here, but he came up with the name Eric the Lab Marsi. But to ComsVNext, flew 3 laptops, a bunch of networking hardware, you name it, because I did not have a way of accessing my network remotely. And pretty much had 3 Skype for Business pools, 2 Exchange servers, you name it, on site. Going through TSA was not fun for that trip. Thankfully today, don't have to worry about something as desperate as that, because I do have business internet now. But I like building environments out and not just reading documentation, but actually building it and learning from an actual example is what I personally believe is beneficial, and it's also what has helped me get to where I am today. And so I'm very thankful for everything I've been able to do, and looking forward to the future, and keep on labbing it out. So let's go ahead and hop into the content for today's presentation, and we're going to start off with SBC high availability. And we're really going to start talking about 3 different modes that I kind of look at when you talk about SBC HA. So the first one that we want to look at is active and passive. And this is what you typically hear when you hear about SBC high availability. Only one SBC is active at a given time. So you have either 2 physical appliances or 2 software appliances. Now, what would be a pro of doing this? So only one SBC license is needed in this topology. So if you're wanting to have high availability without having to spend additional money for additional concurrent sessions or additional features on the SBC, a single license would be able to span across both boxes depending on kind of how your vendor sets that up. The benefit also of this is that you have a single endpoint to manage. So whether or not you're changing routing, you're changing trunk configuration, whatever that may be, you have a single point that you are configuring. You're not managing two separate instances of SBCs. At the start of that, to set the HA pair, you are, but after that is done, you are not. Now, what would be a con of that? And that con would be you are not getting additional call flow or session support by having two SBCs. Because while one is active, the other one is completely disabled and just sitting there in a standby mode, waiting for the first SBC to fail over. So the other form of SBC HA is active-active. This is where you have two independent SBCs that are pretty much, you can have them right next to each other, you can have them at two different locations, whatever works for you. And this will provide double the call capacity of what a single SBC would provide. And then that way also you're load balancing incoming and outgoing calls to your environment. So think of it like this, that if you have incoming call, it's coming in from your SIP trunk, it can go to either SBC, and both SBCs are both configured in the exact same way, as long as you're keeping configs in sync. And it will route directly to Teams without any type of additional intervention. Now, the cons to this is that you need either two physical SBCs or software-based SBCs, but you also need double the licensing, because now you've got two SBCs, let's just say 100 concurrent sessions each. And because of that, you're going to be spending a little bit more money to have an active scenario. Now, the other big things that I mentioned a little bit is that you're going to have two endpoints to configure. So if you want to change a routing rule, it is not going to sync automatically to your other SBC. You have to make sure that you make those changes at the exact same time on both SBCs in order for that to route correctly. So that's kind of the active. Now, this really isn't a typical name. I call it active-passive squared. And this is where you've got a very highly available solution at a single, let's say at a single site for this example, that you need two active SBC pairs. You also need those to both be redundant, so that either SBC fails, another one takes over an active pair. So this really isn't common to see, but it is, kind of something that somebody may run into in a very critical environment. So one big thing with this is that it does provide the additional call capacity, like active SBCs. The difference being is that even if the SBC itself fails, you're still going to have another SBC that'll fail over and still give you, let's say, 100 plus 100 sessions, so you have 200 sessions. In an active pair that we used to look at on the past slide, if one SBC fails, you're only going to have 100 sessions. You're not going to have that additional call capacity. So even though you're running an active scenario, you still need to plan and make sure that you have a solution available that in the event of a failure, that you're not over subscribing that SBC. So you're not trying to push 150 or 180 calls through it. So you kind of need to plan that when you are deploying, designing your solution. So back to active-passive squared, I'll call it. Two SBC licenses are still needed, but that spans across all four SBC and two SBC pairs. Now, like active-active, this does provide two SBCs that you have to manage independently, but you have that high availability in mind. So before we kind of continue, does anybody have any questions? So what does active or a kind of active-passive squared scenario look like? So this is my environment where I have two SBCs deployed. And we can look here on the right side, and we can see that everything is exactly the same in terms of the configuration, even though it's all manually configured. So you can see the number counts are exactly the same, and then our topology is going to be looking exactly the same on these two SBCs. But they are both separate, and that's kind of one of the big things that I wanted to push, is that you can still manage them independently, but they are two separate devices. So outside of SBC high availability, we're going to look at geo-redundant routing. And so this comes down to what is going to be unique to your organization. routing in Microsoft Teams can be designed in so many different ways and in so many different scenarios that there is not one set answer. It really comes down to your business requirements. Having different voice routes or different voice routing policies allows you to route to different SBCs in different locations and be able to design a plan on how you want that to look in your organization. You could have just SBC preference and sending all numbers as one solution. Not my personal recommendation, but or you could say, hey, if I have these US numbers route to this SBC, if I have these US numbers route to this SBC, or if I'm going international route here, that way, let's just say you have a different SIP carrier for each, that you're minimizing your costs with those SIP trunks. So here in the diagram on the right, we can see that we have an organization that has voice routing policy 1. And this voice routing policy has 2 PSTN usages, and these are so that's just US numbers and international numbers. For voice route 1, we are saying, hey, if you're trying to get to emergency services, so 911, 999, US is 911, but UK is 999. Or if you guys want to go IT crowd and you want to do the 0118 and do the full number. This is saying that, hey, either SBC1 or SBC2 can accept this call. We don't care what that preference of that call is. However, if you're going to get then to national numbers, we're going to go to voice route 2. And we're only going to try SBC1 because SBC1 has a SIP trunk or something in that scenario. Now, if SBC1 is unavailable, we are then defining that, actually this diagram is a little bit wrong, that should be SBC2. We are saying, hey, SBC1 is not available, go to SBC2. Now, if the number that was dialed after it was translated through your dial plan does not match that PSTN usage, we're going to go to PSTN usage 2. And right here is going to say allow all phone numbers. So right now, just for international numbers, we're saying just pass through all digits. We're not even doing any type of, if these numbers, and pass those SBC 3 or 4 because we know that those SBCs are for international dial. Now, if no route is available, the call is going to fail. There's nothing else in the tree that allows that call to route out. Now, if, for example, there's a match in PSTN usage 1, so one of those voice routes matches the number that you dialed, it is not going to continue on to PSTN usage 2. It is going to end at PSTN usage 1. So you got to be careful when you're designing this. So it's kind of a top-down approach, so specific to least specific. So we're going to look at a couple examples, and these are pretty much right off Microsoft's site, but kind of getting an explanation on these is going to help you in your voice routing deployment in your organization. So we have a Teams user on the left, and we have a number pattern that says any number that starts off with +1425 or 206, we're going to route to either SBC1 or SBC2. The thing here, though, is that that is a random value. That is randomly selected. Even if you put the gateway list as 1, 2, 3, 4, it's not going to say, okay, we're going to try 1, then try 2, then we're going to try 3 and 4. It is going to try a random SBC in that area. Now, it's also going to try every SBC in that area, but it will be at a random value. So if you do want to get specific, you can create 2 separate voice routes for the same number pattern. You have it try SBC1, SBC2 first, and then go to SBC3 and 4 if SBC1 is not available. And we can kind of see that over here on the right side where we have 2 of those voice routes. Now, in example 3, we get a little bit more kind of back to that original diagram that we discussed, where we have a combination of 1 and 2, where we have anything 425 or 206, we're going to send out via SBC 1 through 4. And we're going to try 1 and 2 first, and then 3 and 4, but in that order. So either 1 or 2 or 3, and then 3 or 4. Now, if the rule does not match that, we're then going to say, okay, hey, if it's a US number that does not match the above, we're going to try SBC 5 and 6. Now, one thing that I mentioned before is that if there is a match and there's not another match, even if there's like a different match further on in the dial plan, not the dial plan, the voice routes, it is not going to match that third voice route. So even though 42526 is technically matched by that last statement, it's not specific and it's becoming less specific. So it's not going to try to route the call to SBC 5 or SBC 6. If it does not get out SBC 4 or 3 or 4, it is going to end that call. Real quick, before I continue, anybody have any questions?
Any questions in the room? No, we're good.
Cool. Go back here. So extending on that diagram even more, and we have the exact same, 3 voice route PSTN usage. We're going to add a separate PSTN usage that says, hey, all international numbers, we're going to just pass through every single digit that is sent to Microsoft Teams, sent from Microsoft Teams to the SBC. And that's going to go to specifically to SBC 2 and 5. So the thing here, though, is that because if you're dialing a US number, it is going to match one of those previous rules. If it does not route by that last voice route in that top PSTN usage, it is not going to route to the PSTN. Only if there is no matches will it continue on to the next PSTN usage. Now, the PSTN usages are ran in order. So however you define the PSTN usages in Microsoft Teams, it's going to say we're going to try US, Canada first, and then try international. It's not going to be a random value like it is with the SBCs and the voice routes. So as we can see here, let's just say we dial 011, insert UK number here or Mexico or whatever. It's going to match that last PSTN usage, and it's going to go out that voice route that says, hey, let's go to SBC 2 or SBC 5. And again, if it doesn't work or it doesn't route out those 2 SBCs, it is going to go ahead and fail that call. So as another what-if scenario, we have an organization that has 2 sites, one in California, one in New York. And we have an active passive SBC pair at each site. So that's just a single SBC at each site in a logical stance. You actually have 2 SBCs. And we have 2 voice routing policies for these users, because if we're somebody that's in New York, and the reason why I chose these 2 different geographically different areas, and for anybody not familiar with the US, that's left of the United States, right of the United States. We don't want to be assigning something that prioritizes an SBC that is in California first for somebody that's on the opposite side of the country, because you're going to have a lot of latency, you're going to have a lot of issues there. So in this very basic scenario, we're going to say, hey, we're going to have voice routing policy 1 and voice routing policy 2. We're just going to make it simple. We're going to have a single PSTN usage for each. And then we're going to have voice routes in each. Now, voice route 1 is going to be again to emergency services. And we're saying, hey, get out to emergency services. We don't care what SBC you go out, whether you get through SBC 1 or SBC 2. We don't care. We're going to get you out to the emergency services. However, but if we're dialing our US numbers, we're going to want you to go through SBC 1 first if you are in California. And if you're in New York, we're going to have you go through SBC 2 first. And so by statically defining those, we're still able to have that redundancy that you would get with geo-redundant routing. But we're going to prefer what we have locally first before we try to go something outside of our local area or geographic area in the country. So we can kind of see that over here on the right side in the diagram that I did provide. Anybody else have any questions before we continue on? Cool. So we're going to go ahead and now talk about Survivable Branch Appliance. So this is kind of the big mystery that around Microsoft Teams, is that there's documentation on it, but there's really not that much documentation on it. And kind of my goal for you guys today is to really describe what an SBA is and how it actually works within Microsoft Teams. So in the event of a Teams service outage or an internet service outage, SBA appliance keeps your PSTN services alive if you are a DR customer. So in an example, if Microsoft Teams has a certificate issue again, knock on wood, we had that last year. What we're going to have as an issue is that the Teams client is not going to be able to authenticate or do additional things in the client, but there is a active registration to an appliance that is saying, hey, I'm here if needed, if you cannot reach Teams, and we can route out via me in the event that, hey, we have no access to the Teams service. So today, this is a separate appliance or service from an SBC, and this really comes down to the manufacturer, the SBC. So for at audio code for like RIP and SBC, there is a separate virtual machine you do have to deploy in your environment. However, if you're using an AnyNode SBC, that is just a service that gets installed on it because it is already running Windows. So it's kind of cool. You can kind of have an all-in-one solution with some vendors, and you can have, two-part solution with different vendors. And it really comes down to what your sizing requirements and the needs of your organization are. So if I want to deploy an SBA today, what do I need? First thing first, you do need to have media bypass control. So you're going to make your security teams pick out. You're going to pretty much have to deploy media bypass, have that firewall hairpin rule in place. You're not like it. It's just something that you need at this current time. Additionally, you're also going to need to open ports 4444 and 8443 on your firewall towards the SBA so that it can communicate with the team service and receive configuration data. Now, if your organization is using local media optimization, and for those not familiar, local media optimization is the way to access an SBC behind a quote-unquote proxy SBC that you have in your environment that may have PSTN services, not a direct connection to the internet. And that's just kind of one little scenario. You could have a whole discussion on LMO, spend quite a little bit of time on it. But if you are wanting to utilize an SBA, local media optimization will not work. And this really comes down to the SBA service not knowing where you are on the network. So with local media optimization, you have to define all your sites and all your subnets so that the team's client can determine if you are internal or external to your network. And if it cannot reach the team service making a call, it's unable to do so, which is where local media optimization will fit. Now, today it is only supported by the Windows and Mac client. Teams, phones, displays, rooms, 3-pit devices, direct SIP, and web clients are not supported. I personally suspect that they'll start adding phones and stuff to the solution, but there's nothing publicly about that, and we'll see what Microsoft has to say about that. And pretty much any of those devices, if you're using them with your team's deployment, you're not going to be able to use those while they're in an offline state. Only right now today with the Windows client. So what is the experience while you're using an SBA? So while the team's client says, hey, I'm offline, I cannot reach teams, whether it be an internet outage or a service outage, what can I do? You're not going to be able to chat, you're not going to be able to join meetings, you're not going to be able to do a lot of things, but you're at least going to be able to make and receive PSTN calls, and you're going to be able to put those calls on hold and be able to resume those. You will not be able to transfer to other people because it is going to be having to reach up to the team service, and that is not a possible scenario with the SBA. So as mentioned before, we have separate appliances from Audio Code, Ribbon, and Oracle. AnyNode SBCs do have that built in. Now, what happens from the back end of the SBA? So when a user signs into Microsoft Teams and it says, hey, I'm on an internal network, I can reach the SBA appliance, the user is going to register to the SBA appliance via integration with Azure AD. So there's actually an app registration built inside of Azure AD that says, hey, this application, this SBA appliance has access to the Stipend Teams tenant admin APIs, and it's a custom API permission that they have for the SBA, and it's able to read user data from your Microsoft Teams tenant. Also, with that, after about 15 minutes is when that user registration to the SBA appliance will occur. Now, Teams will never use that SBA appliance as long as it can still connect to the Teams service. If you kill your internet connection or something happens that causes a connectivity issue with Microsoft Teams, then that one is going to go over to the SBA. Additionally, E911, call forwarding, reverse number lookup will not work because those are all requirements of service. That is all done server side and not client side. So if you do dial 911, you need to make sure that your organization has some type of static configuration for your line URI that says, hey, I'm at this location, and using E911, you typically get floor or switch port or however you have that deployed location. But without having E911, you're able just to say, I'm at this address and program that in with your carrier or your E911 provider. So I did hijack AnyNode's SBA call flow diagram. It is one of the better diagrams out there. So let's go ahead and fix this. And this just kind of shows that, hey, in the event of a Teams outage and your Teams client cannot connect to Microsoft 365, that call is going to initiate directly to that SBA appliance. The SBA appliance is going to go right to the SBC, and the call will be forwarded to the VoIP provider. And again, that is just a basic in and out phone call. We're going to put the call on hold. There's no other features that are going to be available to you. Now, if you are using a SIP provider and let's say your internet connection at the site goes down, you're going to be in for a little bit of issues because now you have no way of getting to the PSTN. Hey, great! I got a SBA appliance deployed, appliance registered to it, but I still don't have internet. So when you are deploying this, it's usually safe to have a dedicated carrier SIP trunk, be another carrier from your internet connection, or if you want to go really legacy, get some PRI trunks into your organization. But you want to make sure that your PSTN service is also highly available in the event of a local internet outage. So all this info is cool and such, but let's get down to one of the biggest things of this presentation. Let's break the lab. What really can go wrong with doing a live demo? Before we hop into the lab, I do want to start off with a quick overview of the topology that we're looking at today. So we have two sites of my quote-unquote organization, and we have site OH1 and site OH1 guest. I just simply use my guest network to try to pull the SBA appliance in because I was too lazy to kind of virtualize an entire other site. But at the primary site, we do have an active SBC pair, and each SBC is reachable at a random value. I'm not specifying to go to SBC1 or SBC2 first. It is at a random value within inside of Teams. And then site OH1G, the user has a voice routing policy assigned for that. It's a single SBC. It's got the SBA appliance. They're only able to talk and reach to that SBC. So let's go ahead and hop in here. So going back to the diagrams we saw previously, we have both of these SBCs, and they are mimicking the configs precisely to one another. So they are different, but they're also very precise. So it's an active scenario. And for starting off, we're going to go ahead and make a phone call. And for this, what we're going to do is to look into it. We're going to go ahead and start a audio code syslog session. And then we're going to go ahead and bring up our Teams client here. And we're going to make a phone call out. This is while everything's still fully online. And so by making this call, this is going to an internal static response group that's routing through the SBC. But we're going to go ahead and look at SBC1. We're going to see, hey, we have no calls that have hit our network. So again, back to that random value, it's going to try either SBC that it can reach. So now if we look at SBC2, great. Now we can see the spike coming in from Teams. The SBC made a routing decision. It's going to SBC2. It's going to SBC2, going right to my Skype environment. Cool. That is it in a working scenario. So what we're going to do is we're going to go into my firewall. And we're actually going to change this up real quick. We're going to say, hey, we want to go ahead and block SBC2 from talking to Microsoft Teams direct routing. So we're going to go ahead and save that. And we're going to enable this rule. And we're going to click apply. What's going to happen in the background is we're kind of simulating this SBC is not reachable by the Teams service. Here, after the SIP options timer times out, we are going to see that the connection up to Teams direct routing is going to turn yellow and say, hey, it's not reachable. And once that does happen, we're starting to see that. So it's showing the proxy alarm, hey, server is down, but we're still waiting for it to bring the actual IP group down because it's trying to figure out, hey, am I able to try getting out to SIP PSTN Hub 2 or 3 or trying a different URL. So if we go back here, we're still green. We're going to kind of wait for that to go down to 2. Give that a second. Okay, so this thing would let's disable options and re-enable options.
Eric, back in the day, you just restart the mediation service to speed it up. Can you restart the Teams mediation service?
Yes. So since this is doing this, let's go ahead and try to make a phone call. Let's see what happens. Bring this call into our SBCs. We've got that call going on right now. And let's go ahead and pull up syslog viewer. And if we notice, we do not see that call coming into the SBC that routed directly to SBC1. Now, this may have just been because of a random value. So what we're going to try is we're going to try to make a few more calls and see if we can see where it hits SBC2 instead of SBC1 first. Okay. So now we see that we had a call into SBC2 there, but go over to SBC1. If we go over to SBC2, we do not see that we had that secondary additional call. So there's still that just one we had originally when the service was up. So automatically, without any user errors or anything being presented to your user, we pretty much have simulated what happens during an SBC outage. And that is where the team service itself cannot talk to the SBC. Now, if I do bring up my firewall again, and we go ahead and disable this, we will see that everything comes up. However, what happens if I block both of an SBC1, if I block both any access to the internet or pretty much anything? So we're going to see SBC2 is over here and it's saying, hey, everything's great. I've got green check marks across the top. I'm good to go. But SBC2 here in a second, SBC1, I'm getting flipped, I apologize, is going to start off reporting, hey, I cannot get to the PST and I cannot get to direct routing now that this firewall blocking rule is applied. So let's give it a second here. Okay, we're starting to see some of the warnings coming into the SBC. We are going to bring up the Teams client along with syslog viewer. We're going to clear all those sessions, and we're going to make a phone call coming into our environment. Make a couple more just so that we have call coming in. And if we look at SBC1, and apparently that still made its way in. Awesome. It's always fun when things don't work, right? Yep. All right, cool. So yeah, so that did not work as planned, unfortunately. That's joys of doing things in a live demo. Now, what happens if both SBCs are unavailable? And this is going to act as if both SBCs are unreachable by the team service, and it is also still not working. This is awesome. There's literally no routes going to that subnet, and it is not working as planned. All still connected. Awesome. So that did not work as planned, but in the event of a dual SBC outage, the call will terminate. But in the event of just a single SBC outage, it is automatically going to fail over to the other SBC that is available in your environment. So I do apologize on that not working as correctly. I mean, it worked last night, but you guys know how the demo gods are usually not in your favor. So that is kind of a failover in an active scenario where you have two active SBCs. This is the part where I was going to show off the SBA feature, but that is unfortunately not working as well. But what I will show you, just so you guys are aware of what it looks like from an SBA side, in case you've never played around with an SBA, is that what it looks like from the client, the server side. So let's go ahead and log into this AnyNode SBA that I have running, and give it a second. And we're going to go over here to extras and the AnyNode SBC, and we're going to see, hey, we've got the Microsoft Teams SBA appliance running on our box. We have a Teams SBA service that's running in Windows, and if this was an additional like an audio codes or ribbon SBC scenario, that would be running as a service on that virtual machine. In here, we have our configuration, which is tying it to the Azure application ID. And then the SBA users is where you'll be able to see a list of all the SBA users that are registered to this SBA client. So in your organization, if you've got, let's say, two separate SBAs, you've got two separate SBA policies that are going to be assigned to your users. And only the users that are assigned to that policy that's tied to this SBA are going to appear in this list. This is the part that unfortunately was not working for some reason, even though I'm using a full desktop phone. Not sure why that stopped working for deployment, but another fun one that's going to put out. So there's that. So with all the issues and things that did not work out as planned, does anybody have any questions?
Hello. Any questions for Eric in the room?
I do have one, Eric.
Mm-hmm.
So can you clarify, I have an SBC or the SBA, and I can't connect to Azure for authentication. How does it handle it when someone comes in first thing in the morning, fires up Teams, and tries to connect in? How does it authenticate that?
Very good question. So if the Teams client knows about the SBA, if it has ever once known about that SBA, it will attempt to register to the SBA. If you're not signed into Teams and you start your computer up brand new, and let's say you have no internet connection, that Teams client, let's say it may not know about the SBA appliance, you're not going to be able to connect to that SBA because there is not that initial authentication to get the Teams client up and running and get that initial registration to the SBA going, so you won't end up in a scenario where you're kind of up a creek without paddle.
So basically, it's because the Team service has told the Teams client before this SBA is a trusted endpoint that in the
Correct.
future we
Try to use it if it still remembers that it has that. And I've not seen it working when I've tested it in that scenario, but that's kind of how it's supposed to work. Supposed to work TM. But in a scenario, if you have not been signed into Teams, it is pretty much safe to assume that you're not going to be able to register to the SBA. It's just kind of something that you want to be aware of.
Right. Thank you.
Any other questions in the room, or for our online audience? If you've got a question, just raise your hand and I can unmute you. This might be another session that the presenter's done such a good job. There's no more questions.
I don't know if I would say such a good job. Things aren't working as expected, but
you can't do anything with the demo, guys.
Yep.
Oh, hey.
Oh, we got one.
Here you go. Let me.
Eric, thank you very much for the presentation. Why do you think it didn't work? Must, yeah.
I just have to say one thing. Cisco ASA. That's the whole reason why it didn't work. So I am so everybody's aware, I am working on replacing that because those do end up end of support come next August. So I am.
That thing was end of support day one. That thing was garbage. As a former Cisco ASA firewall admin.
I am actually going to be replacing that with a Palo Alto, but it's just, hey, can you guys give me some NFR licensing? Question mark. Fingers crossed.
You don't have an endless amount of money just to buy enterprise class equipment for your lab?
No.
Oh, okay.
You actually have to probably see it right here. I don't know how much of my speaker view you guys can see, but this is actually the server rack over here. It's a 48U rack. It's got 3 physical hosts and all this other crap in it. So I've probably got a VM for something. That kind of goes back to my first slide. So.
Got a quick question. Has anyone actually deployed this? Do you know anyone that's using this in production?
Of my customers, no. I have not actually seen anybody deploy the SBA appliance and actually use it yet. The only testing that I have done has been in my own lab environment.
You got someone, have you? You tried it and... Yeah. I mean, I can understand in the Skyway, I've got hundreds of these SBAs out there, and you know, because the client signed in for 120 days, so you get survivability. There's so many, this doesn't work, that doesn't work, that scenario, that doesn't work with phones, so I can't see anyone using this until it works with phones, really.
Yep.
Yeah. Cheers, thanks. Great demo, though. Great.
No problem.
And we're showing your whole view behind you now.
Yeah, we can see all the room now.
Pile of phones.
Okay, cool. Yeah. So over here is the server rack. So
Yeah.
I don't know how that's working out. I can only see a little tiny square.
Is that still the table of phones behind you, or? Because
That's just a table of projects. The phones are now in like 3 giant totes.
okay. The old phones I sent you are in totes. They were in totes at my place.
So they're in totes right now because I needed my desk space. So everybody's aware. Just so everybody's aware. Michael was gracious enough, but probably like a little over a year ago now.
Yeah,
when
we traded.
We traded a bunch of stuff. What was it? Your firewall or something?
Yeah, you sent me the Ubiquity firewall, and I sent you like 6 old phones and like $300.
Yeah. So yeah, it was quite fun, and I've got most make and models of phones, whether it be Teams or Skype, and part of that is thanks to Michael. So everybody, give a clap for Michael.
There you go, Michael. You got your own applause.
Thank him for being the junkyard for old phones.
Any more questions in the room or from the online audience? Raise your hand if you have. Last call, I think.